At this point in the lesson, you may have thought about function overloading with function templates, and that is what I'll talk about in this video. A function with the same identifier can be overloaded by template and or non-template functions. Now let's talk about how overload resolution is going to work when you have function templates and you do overloading. Your template functions are instantiated through argument deduction. Then you have something called the candidate set, which is the non-template functions and the instantiated function templates as well. In other words, if argument deduction is successful, then you get a specialized instantiation of that function, or in other words, a generated version of that function by the compiler. Then the functions in the candidate set are compared to determine the best match. Two important points. The non-template function is chosen even if a template function would be an equally good match, unless explicit template arguments are specified. If the non-template function requires a conversion, then the template function is chosen instead. As an example, let's have a non-template function with a integer as a formal parameter, but you pass in a double as an actual argument. Then it's going to choose the template function instead, because it's going to have to do a conversion from double to int, in which case you can lose some data, right? Now that being said, if the overloaded function has a formal parameter of type int, and you pass in an actual argument of type int, then it's going to choose the non-template function instead of the template function, because the actual argument with the integer type is a direct match for the non-template function with an integer formal parameter. For this example, I'll use a simple print function again. We have two function templates, and up here, this function template has one type parameter and one formal parameter as well, which is of type t, and it's going to print out from template. It's going to do a new line, and then it's going to print out the argument basically, so what we pass in is going to print out. Now I have another overload of that. Remember here the identifier or the name of the function is the same, but in the second function template, I have two type parameters in the type parameter list and also two formal parameters. And I'm also going to print out from the template, I'll print out argument 1 and then argument 2. So parameter 1 is going to be argument 1 and parameter 2 is going to be argument 2. Scrolling down a bit, I have two non-template versions of the function print. In the first example, the formal parameter is going to be of type integer. This will print out cout from print and int as the type. And I'll just print out the argument as well. And then I have another one here, another overload, and the formal parameter in this case is a pointer to an integer constant. Okay, and it's going to print something like this out from the print function that has a pointer to an integer constant for its formal parameter. I'm going to print out the argument again, and notice in this overload I have to dereference the parameter because it's going to be a pointer. Otherwise, again, we'll get an address printed out right here. So I'll go to main now, have this constant integer x, which I initialize to 4, and then I invoke the print function a couple of times. What do you think is going to happen when we print out the character h? Well, we do not have a non-template function with a type of character as a formal parameter, so it's not going to choose one of these. And because of that, the best option is going to be the template version of the function. In the next statement, we do print and we pass in x, and that should choose this version right here, which has the type of integer for the formal parameter. And then in the next statement, we explicitly specify the type argument integer, so it's going to use the function template. In the next statement, we pass in the address of x, and x is a integer constant, and so it will use this version of the print function. And then right here, in this statement, we have 55 for the first argument and r for the second argument. We do not have an overloaded non-template function that accepts two arguments, so it's going to use the template function, this one right here. Okay, because that has two formal parameters. And remember, the types can be the same or different, so you can pass in two integers for the type arguments, or they can be different. And with this, argument deduction is going to succeed, and the compiler is going to generate a function. In other words, it's going to instantiate that template function, and the first type parameter is going to be set to type of int, and the second to type of char. And actually, if I hover over this, IntelliSense helps me out again. It basically shows me the specialization, so it's going to be void print, int for the first type parameter and char for the second. Let's build a run. Just squeeze that down a bit, move this around a bit, and this is the output that we expected. So from the template it's going to print argument h, and then from print int it's going to print out 4 for the second statement here where we pass in x, and then here where we explicitly specify int for the type argument is going to print out from the template. It will print out 4, and then for the next statement where we pass in the address of x, it's going to use the non-template function that has a parameter of pointer to integer constant. And remember, we do reference in that, so it's going to print out 4. And the final statement right here is going to print from the template as well. The one that accepts 2 arguments. So the argument 1 we can see is 55, argument 2 is R. And just to show you here that both of those can be integers as well, I'll just remove all of that actually, build and run. And you'll see that works fine. So with your template again, just because you have 2 type parameters does not mean that your type arguments for those parameters cannot be the same. With this statement right here, the compiler is going to deduce type argument of integer for both of those. And then also, as I mentioned, let's say we have 55 here, right? That is an integer, so it's going to use the non-template version of the print function. Build and run that. You can see it uses that version of the function, the non-template version. And now what's going to happen when I put a float or a double in here? I'll build and run. And as I mentioned, it's going to choose the template version or overload instead, because otherwise, let's say it chose this non-template function, this version of the print function, then of course you can lose data because it has to convert a double to an integer, and you don't want that. So instead of doing that, it's going to use the template version of the function. Okay, that is going to wrap up this video. Hope you found this interesting.